Hello everyone. This video is to show you how to use a two-tailed hypothesis test and what type of a test you'll run, how to use Excel to do it, and what that would look like in an actual statement form. So as you can see, I've got some data here looking at 2019 data from North Dakota, South Dakota, Nebraska, different agricultural districts. We're looking at the corn yield measured in bushel per acre, the soybean yield measured in bushel per acre, and the rental price for cropland measured in dollar per acre. This is my whole population. I have 20 different data points, just like you should have in your sample set or in your project. You should have 20 total elements that represent your population. I also did a random sample over here. I gave each one of them a code, and I calculated or used the data analysis to calculate a random sample of 12. So here are my 12 random data points down here, or my random sample. For my population, I have the descriptive statistics over here for each one. You can see the mean, median, mode, standard deviation, range, all of those things. So now that we have our population descriptive statistics, and our random sample, we can go into my hypothesis statement. So my null hypothesis is that the average price of rental cropland is equal to $125 per acre. We're going to be looking at a two-tailed test because we want to see null hypothesis, $125 per acre, and the alternative is just not equal to $125. It could be greater than or it could be less than. So if you think about that curve, we're looking at the two extremes, to the right or to the left. So here's how we're going to do this with using Excel. Unfortunately, there isn't any masterful formula that's going to show us how to do this. So we're going to do something, we're going to create our own. So we're going to use givens, starting with a sample mean, and then we're going to look at the mean of the sampling distribution, which is assumed to be true. That would be that 125 that we were looking at. Looking at the standard deviation of the population and the sample size. So once we have all of those, we're going to be able to use Formula 9.1 on, what page is that on? Formula 9.1 on page 389 to figure out our critical scores, our z-test statistic, p-values, and all that. So for starters, the sample mean, we have to calculate that. We are obviously looking at average price of rental cropland. So equals average. And I want cropland of my sample, so I'm looking at the random sample, as you can see. I want the average of these data points. Close up my parentheses, and we end up with 91.41. If you don't like going back and forth between pages like that, you can always do all of this on one. I just wanted to show you what it looks like. So then the mean of the sampling distribution, which is assumed to be true, that's that 125. Whoops, we don't even need equals, just 125. We are assuming that the average is 125 unless we reject this. Now we need the standard deviation of the population. Remember, this is true for when we know that standard deviation of the population, which we do from these descriptive statistics. It's about 53.3. So hit enter, and then our sample size is just simply 12. So those are all of our givens. So the next thing we need to look at is calculating a z-test statistic and also the critical z-score. So when we calculate that critical z-score, what we're going to use, here we can use a fun little formula. We're looking at the normal sample.inv. And our probability is going to be 0.05 because we're looking at that 95th percentile for our confidence interval. So we want that 5% basically, but because this is a two-tailed test, we need to divide that by 2. And we'll find that our critical z-score is negative 1.96, and that's also going to be true on the right of 1.96, so positive and negative, because it's that two-tailed. So to calculate that z-test statistic, we need to put in this lovely formula on page 389. So we're taking our sample mean, we got lots of parentheses, sample mean, we are then subtracting the mean we are assuming to be true, that 125, close up that parenthesis, we are then dividing by another parenthesis, the standard deviation of the population, and dividing that by the square root of our sample size. And we have to put 2 parentheses there because we're closing up both of those parts of the formula. Hit return. And we get a z-statistic of negative 2.18. And if you think about the way that distribution looks, negative 2.18 is further to the left than negative 1.96. So that should tell us that we are going to reject our null. But let's find that p-value just to make sure. So to find our p-value, what we are doing is we are going to again use a formula here, now that we know our z-test statistic. So we are going to use that norm.s.distribution function, and then it says z cumulative, so z-score, comma true, and hit return. Now again, that's the p-value for one tail. So we need to do times 2 because we're looking at a two-tailed test. So equals our p-value times 2, and we get a p-value of 0.029, which is basically 0.03. That is below a p-value of 0.05. And what that tells us is that we are going to reject our null hypothesis. So we come back into our Word document, and our conclusion we are going to reject the null hypothesis and conclude, if I can type, that the average price of rental cropland is not equal to $125 per acre. It says, and that's what you would come up with if you rejected it. Now let's try this again with a different number. So let's come down here a little further. All right. What if we said that the average price of the cropland was 103? That 103 is coming from the fact that the actual average of the population was 103. Or I guess we could say 104. Let's do 104. $104 per acre. Let's get rid of that. Let's see what happens when we change it. The cool thing is we've already got it set up, so all we have to do is change that assumption. So now instead of assuming that the average price of cropland is 125, we are going to assume that it is 104. Now, when we did that, our z-test statistic is negative 0.18 or 0.12. 0.82, excuse me, or 0.817. So again, if you think about that distribution, negative 0.817 is not to the left of that critical z-score. But then we also look at our p-values. We've got some pretty high p-values. So that's telling us that we are failing to reject our null. So when we come back for our conclusion, we would type in that we fail to reject the null hypothesis and conclude that we do not have enough evidence to state that the average price of rental cropland is not equal to $104 per acre. So that is two different ways, or two different hypotheses being tested for a two-tailed test. The first one, we rejected our null hypothesis and concluded that we had enough evidence to state that the rental average price of rental cropland was not equal to $125 per acre. When we redid it with a new assumption of 104, we were unable to reject the null hypothesis, so we failed to reject the null hypothesis and concluded that we did not have enough evidence. So the first one we did have enough evidence, the second one we did not. So basically we're saying until we can find enough evidence, we are going to go with that status quo, that assumption that $104 per acre is correct. And that is how you would use Excel to conclude the p-values and the t-test statistics for a two-tailed hypothesis test.